Hello everyone. In this video, I will be discussing a tutorial of all of these four problems which has been asked in Leetcode Weekly Contest 480. And this contest has went quite well for me as I got quite a decent rank, as you can see. Uh, by the way, this is my best rank till now in any contest. So I thought, why not let's just make a tutorial. So without further ado, let's start the video. So let us see the first problem. Okay, so in first problem, you are given an integer array nums and an integer k. Find the absolute difference between the sum of k largest element in the array and the sum of k smallest element in the array. Return the integer denoting this difference. Okay, so in first problem you are given an array and an integer k. So let's see the first test case. So in the first test case you are given nums as 5 2 2 4 and k is equal to 2. So you are saying that return the difference of uh, k smallest element and sum of k largest element. So here two smallest element are 2 2 and two largest element are 4 5, and you have to just sum them up, so it will be 4 and this will be 9, and finally you have to return their difference. So difference will be 9 minus 4 is equal to 5, so the answer is 5. uh, if you want you can check out the constraint as well. So the array length can go up to 100 and k can go up to array length. So the approach is actually quite simple. Uh, you have to just sum up the smallest element, and you have to sum up the k largest element, and then you have to return the difference. So for this you can just sort the array so that the array becomes monotonic. You can sort either in ascending or descending, does not matter. uh, for simplicity, let's sort in ascending order. So the element will look like 2 2 4 5, and then you have to just uh, sum the first k element and sum the last k element and return their difference. uh, and the time complexity will be, because we are sorting the array, so sorting takes in log n time, and space complexity will be, we are just we will just take two variable l and r. L denote the left sum, smallest k sum, and r will denote the largest k sum. So space complexity will be 1, and if you go with the constraint, this will certainly pass. uh, By the way, if you don't want to sort, you can also use two priority queue, one mean heap and one max heap. Then you can pop the from mean heap. You can pop the k element and sum them up, and you can also uh, uh, pop. You can also pop the k element from the max heap, and in that case, and then return their difference. In that case, complexity will still remain the same, but space complexity will vary because you are externally declared to priority queue. So this will not be one, and this will still remain the same. So uh, either way which you feel comfortable you can go. So yeah, this is it for this problem. If you want I can show you my solution. So this is my solution. I have gone through the sorting approach, so I have just first sort the nums array and then declaring two variable to store the smallest case sum and largest case sum. And this is this is how we are calculating the sum, and finally we are returning abs of l minus or you can just return r minus l because right sum, largest case sum will be greater, so you don't have to take absolute function. Now let us move to the second problem. In this problem, you are given a string S consisting of lowercase English words, each separated by a single space. Determine how many vowel appears in first word. Then reverse each following word that has the same vowel count. Leave all remaining words unchanged. Return the resulting string. Vowel are A, E, I, O, U. Uh, I think the problem is quite clear because it is just simple statement. So in this problem, you are given a string S. S will consist of words separated by a space. As for example, in the first case, we have cat, uh, cat, one single space, and mice. So first of all, you have to just extract the words and remove the space character. So if you take out each word and store in a vector or something, then our first word will be cat, second word will be and, third word will be mice. So you have, and in the first word you have to count number of vowels. So in this case vowel is one, and from the subsequent word you have if in subsequent word you also have to count the number of vowel. The only extra thing is that if the vowel is same as this one, then you have to reverse that string and append with a blank space in the answer, and finally return the answer. So uh, in this word there is also one vowel, so we have to reverse this word. So if you reverse this word, it will become DNA, and in this we have two vowels, so the first and third are not equal, so we have to just append as it is with leading one space. So yes, so our answer will be cat, DNA, and mice, and also this is a required answer. And if you see the constraint is up to 10 power 5, so we have to implement in linear time. And yes, we can implement in linear time. You have to just iterate this word, and uh, if you found a space, just push this string into a vector and start again with this word. So it is more of kind implementation problem. There is not much thinking required here, so I will prefer to jump to the solution directly. uh, so this is my solution. By the way, I have not used like uh, any extra vector of a string to store the word. I have just directly did this in the for loop. And for checking the vowel, um, I am storing all the vowel in a set and just checking if this current character present in the set, that means it is a vowel. So it is just implementation problem and not that much hard. What I have explained here is uh, written here, so you can see, and that's it. So talking about time complexity, so time complexity will be uh, time complexity will be n TC will be n log 5, because each time we are checking either character is vowel or not, and I am storing vowel in a set. So this is just a constant term, so we can write this as O of n linear time. And if you see, this is also I am reversing, but the if you talk about the whole string, then whole string will be reversed only one. So effectively you can say O of 2n, or this is simply in complexity term, this is just linear. So this is the time complexity. And space complexity is if you consider the returning answer as a space, so it will be obviously O of n, else it will be constant time complexity. If you have gone through uh, storing the word in a vector, then in that case a space complexity will be linear, but in this case it is constant. So I hope the solution is clear now. So now we should move to third problem. In the third problem, you are given a circular array balance of length n, where balance of I is net balance of person I. In one move, a person can transfer exactly 1 unit of balance to either their left or right neighbor. Return the minimum number of moves required so that every person has non-negative balance. If it is impossible, then return -1. Note you are guaranteed that at most one index has a negative balance initially. I think the most important part of this problem is this line, because this line makes this problem much easier. If you ignore this line, you may find this problem difficult, but if you have carefully read this line carefully, then it is much easier. So formally, let me explain you the problem statement once again with an example test case. So in this problem, you are given uh, an array named balance 5, 1, -4, and you are also said that there is at most one index that can be negative, otherwise everyone will be non-negative, means greater than or equal to 0. So, and if there is negative index present, so sorry, negative value present, then in that case we have to make them non-negative. And for making non-negative, you can transfer 1 unit of balance from any other index that has positive amount. Like if another index has 0 amount, then how can you transfer 1 unit balance? This does not make any sense. So if you have any another index that has positive balance, then you can transfer 1 unit of balance mm, adjacently, means suppose, and also the given array is circular, means index 0 index 0 has neighbor 1, and also 3 minus 1, that is 2. Index 0 has this neighbor and this neighbor both. So in one operation you can transfer 1 unit of balance to this index as well, to this index as well. because as you can see here it is written you can transfer either left neighbor or right neighbor. This means that you can transfer any one unit of valence adjacently, and since the array is circular, so first index is adjacent to last index and last index is adjacent to first index. And uh, one thing to note here is that see in one operation there is a small observation here. In one operation you can transfer one unit of valence to their neighbor either left or right. Okay, but if you consider the initial sum, let's say initial sum is s, and after any number of operation, let's say after x operation, what will be the sum of the whole array? It will still be the s. That means uh, we can say after even if you apply any number of operation, the sum of the array will remain the same. And if our initial sum is negative, then how can you, even if you apply any number of operation, you cannot make them non-negative. Getting? So we can initially check as well if our sum is lesser than 0, then in that case our answer will be negative. And second observation is that if negative element is does not present in our array, then why would I apply any operation? So in that case we have to return 0. So observation first is if sum is lesser than 0, return -1. Second is no negative element, no negative element present, return 0. We will not apply any operation. Okay, so all right. So now if our sum is, that means our sum is positive or non-negative, then in that case we can make we can make negative element non-negative. If our initial sum is non-negative, then we can make this negative element greater than or equal to 0. So uh, suppose see if our sum is greater than 0, then in that case you can make this element even positive. But does that make sense to make this element positive, or we should make only this element up to 0? So it is better to make this element only 0. We should not make it positive, because that will unnecessary cost extra operation, and we have to return the minimum operation. So we will try to make this element only 0, so that our all the element becomes greater than or equal to 0. Okay, so now our goal is to make negative element 0. For that, uh, what we can do, our given array is 5 1 minus 4. See, we have to transfer each unit of balance uh, adjacently. We cannot transfer from here to here. In this problem you can transfer here to here because they are circular adjacent. So But suppose our array is let us say 4 3 minus 1 10. So from here you cannot transfer here because they are not adjacent. So uh, first of all, we will try to uh, mm, shift balance whichever is closer to this index, uh, because this will be the optimal way. Because suppose if you don't see, this index can also transfer balance to this one, and this index can also transfer with this one. And if you ignore this index and transfer balance with this index, then same unit of transfer balance will cost you more than this. Getting? Suppose transfer you are transferring, uh, let us say 2 unit from here and 2 unit from here, then this will cost only 2 operation, and this and it will cost 2 into 2 4 operation, because first 1 unit will you will transfer from here to here, then here to here, here to here. So transferring from this 1 unit from this index to this index will cost you 2 operation, and transferring from here to here will cost you one operation. So first we will try to transfer balance uh, starting with the minimum distance. So minimum distance is this one and this one also. So first we will try with from here and here. If uh, if uh, if our element becomes greater or equal to 0, sorry, requirement is only one unit transfer, because if you transfer 1 unit, then this will become 0. So if our requirement is satisfied with this index or this index, then we don't require to move any other index. So the approach is just simple: start with the minimum distance and move towards the bigger distance. And also from here you can move here, and this in from here we can move this way. So uh, right distance can go up to here, and left distance can go up to here. Here basically they will not overlap, because before overlapping this will already become 0. So the approach is simple. You have to just start with the minimum distance to both side, left side as well as right side, and take out only that amount of values which are required. So right now if you taking out this balance from this index, then requirement is only 1 unit of balance. So this index can satisfy as well. You can also start if you go with this direction as well, so this can also satisfy, but the answer will remain the same because both are at same distance. So this is the solution. Now I will show you my code. This is the first um, oh, this is the first observation I have. I am storing the sum of all the initial sum of all element of array given balance, and if sum is negative, return -1, and we are finding the index where negative element is present. So if negative element does not present, then in that case we have to simply return 0. And initially I am declaring 2 pointer. First one is left I am denoting by a low, and right pointer I am denoting by high. And Obviously, I am uh, taking left pointer as pair and right pointer as a pair because we not only have to track the indices where we have reached, but also what is the distance between these. So you can also ignore this, by the way, because if you take the difference of the target element and current vr, you can get the difference. But this is what I have thought during the contest. So currently, and one more thing to tell you, that this visited array has no has nothing to do here, because I have just actually in the beginning I was thinking something else, but later I realized that this does not require. So this is just useless. And initially our requirement will be just absolute value of balance of negative element, and as you and at any time we find that our balance requirement is 0 or lesser than equal to 0, this we will break out of this loop, and and obviously then we will take out the, suppose we are at index left I, low dot first is denoting the index where our low pointer is pointing, and we will take out the minimum balance, minimum of requirement plus the index that can provide maximum. So if you take out this much unit of balance, then the cost will be uh, minimum multiply by the low dot second is basically the different distance from uh, negative element where it is present. So and we are this much amount we have transferred, so uh, we will decrease this much amount from requirement, and this is for the left case and this is for the right case. And also we are updating that, suppose our left index point, mm, because we are in each iteration we are doing -1 to the left index and +1 to the right index, and suppose they went out of bound of the array, so we can just take the modulus so that it remains inside the array only, and in the finally we will return the answer will denote the minimum operation required. So if you talk about the space time complexity, so time complexity will be just linear O of n, tc will be O of n, and space complexity will be O of, let me see, have I done any, I have not declare any array or something. This is just useless, you can ignore this, that doesn't have any role. So a space complexity will be 1. So yeah, this is it for this solution, and now let's move to the fourth problem. In the fourth problem, you are given a string s of length n consisting only of the characters a and b. You are also given a 2D integer array query of length q, where each query I is one of the following. First query type is ij. Flip the character at index j of s. A changes to b and v changes to 1 a. This operation mutates s and affects subsequent query. Okay. Second query type is uh, 2 comma l comma r. Compute the minimum number of character deletion required to make the substring l to r alternating. This operation does not modify s. The length of s remains same. A substring is alternating if no two adjacent characters are equal. A substring of length 1 is always alternating. Return an integer as the answer, where answer 5 is the result of ith query of type 2 LR. Okay. So in this problem, you are given a string S consisting of only two characters, either A or B. So in example, you are given ABA, and you have to perform two types of query. First query type will be, in first query you will be given two integers 1 and j. 1 will denote the query type, means it is of type 1 query, and this j will denote the index at which you are required to flip that character. Flipping means if at jth index it is a, then convert it to b. If it is b, then convert it to a. And second type of queries is first index will denote the type of the query, and you will be given two extra integer, that is L and R. You have to compute the number of deletion required to make the substring from L to R alternating. And alternating means A, B, A means no two adjacent character will be equal. This is simply alternating means. And uh, yeah, basically you have to, and you have to return the answer for this query only. So now moving to the solution. I hope the problem is clear now. In the problem, you are given a string consisting of only two types of character A and B, and you have to perform two types of query. First type query will update the index. Updating means flipping the character presented this index J. And second query, in second query you have to return the answer of substring L to R, and the answer will be the minimum number of character you have to delete, so that the substring from L to R will uh, becomes alternating. And also for this query you don't have to modify the original string. It is saying that it is only asking the correct number of character you have to delete, not you actually have to delete. But in the first query you have to actually manipulate or modify the original string. So I think the problem is clear. If not, I will take a simple test case. So in the first test case, given a string is a b a, and first query is of type 2 query. So uh, in the type 2 query, it is asking from index 1 to 2 how many characters required to make alternating. So this is our 0 index, this is first index, this is second index. And if you talk about this substring, then it is already alternating, so we don't have to delete any character. So for this query, our answer will be 0. And in the second query, you, in the second query it is given 1 1, means you have to flip the character at index 1, means after this query our string will become a a a. And now you are asking in the third query, uh, you are asking the answer from 0 to 2, from here to here, how many characters will have to delete. So since all characters are same, we have to delete minimum 2 characters to make alternating, because after at least deleting 2 characters, the resulting string will be alternating. Because if if our string length is 1, then it is already alternating. It is given here a string of length 1 is always alternating. So for this query the answer will be 2, and you have to return this vector. Now how will approach this problem? So first of all, just ignore the first type query. Just ignore this type query and focus on answering the second type of query. uh, I mean to say that suppose our given a string is a static, means there is no updation here. So and I am considering just another test case. Just forget about the given example test case. So let's say we have one b a a b b, and if you are asked to answer from 0 to length minus 1, this is 0 1 2 3 5 6 7, and suppose our query is 2 comma 0 comma 7, means you have to return for this substring, means whole string. Then how will you calculate the answer? If you see, I will just you can simply say that I will delete each adjacent equal character, because see, uh, if you delete the, let's say our currently length is 7, if you delete sorry, our length is 8, and if you delete the first 7 character, then our answer and then our resulting string will also alternating. If you remove this four character and these two character, still our resulting string is alternating. But is this method, or is this way of deleting optimal? No, because you are taking more characters to delete. So sorry, so it is always optimal to delete the adjacent equal characters, and that will be the minimum number of characters required to delete to make that alternating. Because see, if these two adjacent characters are already non-equal, alternating uh, alternating means it's simply that adjacent character will not be equal. B is also alternating. A simply, it just means alternate. It is alternating because its adjacent character are not equal. That's it. So we have to answer this query. We have to just count how many adjacent characters are equal, because if you count the equal, then that much character you have to delete, and that will be the answer. So for now I am not considering query 1. So for answer any number of query of type 2, we can just make a prefix array. Let me clear up the board. uh, Let me explain you here actually. So let us say our array is our string is a b b b a b b a, and length of array is just 9 because our index is up to 8. And our query is from 0 to 8. First query is 0 to 8. Then what I told earlier is just make a prefix array where index I will denote uh, this index. Is this character equal to previous character? No, so this will be simply 0. Is this character equal to previous character? No. Is this character equal to previous character? Yes. And is this character equal to previous character? Yes. Is this? No. So if you fill the simply, it will look like this. And if the query is asking for 0 to 8, then we can simply sum the all of the elements. So if you sum all of the element, it will be 4. And and actually we have to delete two characters from here, one characters from here, and one characters from here. So it will give you 4. And if a query come from, let's say, 2 to 7, then in that case, see, our query is from 2 to 7. If you go with index 2, our query is 2 to 7 here. But one thing note here that uh, 2 index is denoting that our this current character is equal to previous character or not. But we are considering only this much string from 2 to 7. So this character does not come in our query substring. So we have to, if our given string is from L to R, then in in the sum of the array we have to query for L plus 1 to R. Sorry, yes, L plus 1 to R. So uh, so in that case we will query for sum of the array from 3 to 7. If you talk about 3 to 7, the sum will be 3. And in actually we have to delete 3 elements. And that element will be, one character will be this. Or any, you you will delete one character from here, one character from here, and one character from here. Okay. Okay. And one thing also I would like to tell here is that uh, whatever I have explained here will be, I have made prefix array considering our current character is equal to previous character or not. But in my solution, I have uh, built the array something like this. Uh, I have ignored this index because I am at 0 index. I am storing is our first character equal to or not. Means in my implementation, our sub a if in prefix array, if p of I is denoting either s of I plus 1 is equal to s of I. So if you're talking about the if you made this if you made a prefix array this way, then your query will be from L to R minus 1, because I'll show you in my solution, sorry, in my submission. This is just template of segment tree. By the way, this all has been written by me, so if you want you can freely copy, modify, or whatever you want you can do. um, See, I am querying L to R minus 1 because I have made this X array or prefix array as this way. So it is just same. If you want you can implement this way, if you want you can implement this way. This is what I thought during the contest, so I just, but I think this is more easier. So whichever way you like you can implement. I would highly encourage you to implement yourself. uh, so that you can understand it more better. So now consider the first query. If suppose see, for handling this query we built simply a prefix array. uh, s- uh, mm, we will build another prefix array because this is just denoting either character is equal or not. So for answering range sum query on a static array, we will build another prefix array and answer then all type. You can answer all types of the query of second time. But if you consider the first type of query, then it will take to then you will have to make this prefix array again, because see, prefix array does not support updates, so you have to build this prefix array again. In that case, the query for second type will be linear. And if you talking about the uh, whole of the query, then in that case answer will query complexity will be qn, which will not pass because q can go up to 10 power 5. So we have to think in terms of q log n something. So if you have read about segment tree or Fenwick tree or something like that, then you can easily recall that these two operations, updating a element and range sum, can easily give you Fenwick or say a Fenwick tree or segment tree in log n. So from here, if you have study a little bit about either segment tree or Fenwick tree, this is the introduction. Whichever tutorial you will see, you will be taught about taking this example only, like range sum and point update. So the approach is for handling fast query and handling both query efficient way. You have to not build prefix array, you have to build a segment tree or Fenwick tree over this array. This one, sorry, this one. Getting? So the approach is simple. You have to build just a segment tree or Fenwick tree over this array. And now for updating, see, if you update any index, then let me show you. Let's say you change it from b to a, then only this index and this index will affect. So you have to update these two index as well, because this index is storing these two either equal or not. So if it is 1, it will become 0, and if it is 0, then it will become 1. Getting? And rest of the element will remain the same. So one query of type 1 will cost you 2 update. Getting? So sorry, this will become 0. This will still remain the same because this you are modifying this index is responsible for this one and this one, so you will have to modify this, not this. And if you have built array using this approach just I have mentioned, then you have to update this one and this one. Yeah, so this is the approach. Just build a segment tree over this or Fenwick tree over this, and each query of time one will cost you 2 update, either this one or this one. And this is the solution. If you talk about the complexity, so building segment tree or Fenwick tree will cost you in log n, and query query will cost you each query will cost you log n, or each update will cost you log n or 2 log n, does not matter this constant. So each query will cost you log n, so overall time complexity will be n log n plus q log n. This is the tc, and space complexity will be linear. So yes, this is it for the video. If you go with my solution, this is just segment tree template. And also if our array length is 1, then for each query of type 2 the answer will be 0. So I have handled it externally. So now we are building the this one 0 1 array. uh, this is, and now we are building segment tree. My segment tree template first parameter consists of the vector for which you are building. Second will consist of the merge function. If you know segment tree, there is a merge function. Basically, if you merge two segment, what will you do? So I will simply add those two, and this is the identity element. Means suppose if um, identity element is suppose you have segmented like this, and uh, in no overlap, what will this uh, DFS call will return? So that whatever will be returned by this side, the answer should not change. So for some, if you not found answer, like if you does not found any answer from this side, then you can simply return 0, because if you add 0 with the other side, then that answer will not change. So yes, and if q dot size equal, if it is query of type 2, then we are just updating the two indices, and we are handling separately index 0 and index last. And if neither the first index or neither it is last index, then we are handling here. And I think you should, rather than watching my implementation, I have explained you my approach. So you should, it is better to, you should implement yourself, because that will improve you a lot. uh, this is, I am not saying this is good implementation, because this is what I thought during the contest. So it may be uh, like complex or something, but if you implement yourself, then that will be much better. So yeah, this is the editorial of weekly contest 480. So thank you for watching. Thank you.